Topic 1, Day 5, Exponent Rules. Exponent rules are not going to be provided on our equation sheets for pre-calc or for IB. Additionally, they're very rarely straightforward exponent rule questions. More often, they're in context of other problems. What I did was include a proof so that if you forget a rule, you can come up with the rule yourself. Our first rule is a zero rule, which just states anything to the 0th power always equals 1. And the way that we can remember this is by writing out 2 to the 2nd power, 2 to the 1st power, 2 to the 0th power, 2 to the negative 1st power, and 2 to the negative 2nd power. And by using calculator or what we already know about exponents, we can fill in for 2. 2 to the 0th power is what we're trying to prove or trying to figure out what it equals. And then 1/2 and 1/4. And what you'll see is this pattern, right? Divide by 2, divide by 2, divide by 2, and divide by 2, right? So in order for that pattern to continue, 2 divided by 2 has to equal 1. All right, so anything to the 0th power always equals 1. Our product rule states that if we have the same base, it's important to recognize that this only works if the base is the same. So here, A and A have to be the same number. Then we can take, this A and this A. Then we have to take M and N, which are our exponents, and we can add them together. And a way that we can figure out why that works is by taking 2 to the 3rd power and 2 to the 4th power. We know that 2 to the 3rd power is 2 times 2 times 2. 2 multiplied by itself 3 times. And 2 to the 4th power is 2 multiplied by itself 4 times. And what you'll see is we have 7 2's, right? 1, 2, 3, 4, 5, 6, 7. So 2 to the 3rd times 2 to the 4th equals 2 to the 7th. And we get 7 by doing 3 plus 4. Next is our quotient rule. We have a to the m over a to the n equals a to the m minus n. And again, it's very important to recognize that our base value a is the same number. The way that we can remember this is if we look at 2 to the 4th power over 2 to the 3rd power and break it up. So 2 to the 4th is equal to 2 times 2 times 2 times 2, and 2 to the 3rd power is equal to 2 times 2 times 2. What we need to remember is that 2 divided by 2 always equals 1. Or any number divided by itself always equals 1. And what you'll see here is we have this 2 divided by 2, which will equal 1. This 2 divided by 2 equals 1. This 2 divided by 2 equals 1. So if we rewrite this, this actually ends up equaling 1 times 1 times 1 times 2, right? And 1 times 2 equals 2. So what we can figure out is that the 2 on the top and the bottom cancel out, right? Because it equals 1. So we can do 2 to the 4 minus 3 power, 2 to the 1st power equals 2. Next, we have power of a product. So if we have A and B are being multiplied, so they're the product part, and we take all of that to some power, that power is applied to the base of A and to the base of B. All right, and the way that we can kind of prove that that works is if we have 3 times 5 quantity squared. So we know that 3 times 5 equals 15, right? But what we can also do is use this rule, 3 squared times 5 squared. And if we evaluate both sides, 15 squared is 225, 3 squared is 9, 5 squared is 25, 9 times 25 is equal to 225. And this proves that we can use our power of a product rule. Okay, our power of a quotient is quite similar, but instead of multiplying, we're going to be dividing or using a fraction. So A over B quantity taken to the m power is equal to a to the m over b to the m. What's very important here to recognize is that it is different from this. Okay, you need the parentheses to indicate that that power is also being applied to b. So this does not equal this. Okay, so if we take a look at 6 over 3 quantity squared, we know that 6 divided by 3 equals 2. But we can also use our rule, right? So 2 squared equals 4, 6 squared is 36, 3 squared is 9, 36 divided by 9 is 4, so 4 equals 4. Now, power of a power, we have a to the m, and then all of that taken to the nth power. And what we can do here is we have 3 squared times taken to the 4th power. So we know that 3 squared here is equal to 9. Or if we use this rule, we know that we can just multiply our powers. So we get 3 to the 8th power. And when we calculate that, hopefully using a calculator, we'll find that both sides equal 6,561. Okay. When you're given a negative exponent, you're just going to put it as a fraction. So if we have, for example, 3 to the negative 2nd power, right? We can rewrite it as 3 to the 0th over 3 squared. And we are using that quotient rule from before. 3 to the 0 minus 2 is 3 to the negative 2nd power. And then 3 to the 0th power, anything to the 0th power, we know equals 1. So 1 over 3 squared is equal to 1/9, which is equivalent to 3 to the negative 2nd power, equaling 1/9. All right. And then our last one has to do with fractional exponents. So if we have a taken to the m over nth power, we're going to do the nth root of a to the m. Okay, so for example here, if we have 3 to the 4/2 power, we know that 4 divided by 2 equals 2. So this is equivalent to 3 squared. But what we can do is take the square root of 3 to the 4th power, take the square root of 81, and then 9 equals 9. Okay. So here's our first teacher example. It's asking us to simplify so that we have no negative exponents. What I'm going to start by is look at our coefficients. Our coefficients here don't have any exponents being applied to them, right? They're not squared. They're not the ones that are any exponents. So we're going to start off, we're just going to multiply them, all right? We don't apply exponent rules if these coefficients do not have exponents. So -2 times 4 is going to be -8, okay? Next, I'm going to start looking at where do I have like terms. So here I have x to the 3rd, and I have x to the 5th, y to the -7th, y to the 8th power, and let's choose one other color. We have z to the 0th power, right? Let's start with our orange. We're going to have x to the 3rd, x to the 5th power, y to the -2nd, y to the 8th, and then z to the 0th power. All of these are being multiplied, so I'm just going to start by using my product rule. That means we're going to add up our exponents. So 3 plus 5, -8x to the 8th power. And then -2 plus 8, we're going to get y to the 6th power. And we know that z to the 0th power equals 1 times 1. This is just written as it is. Okay. Go ahead and try your example on your own. Moving on to teacher example number 2. It says given 3x cubed times 2x to the 5th equals 6x to the power of b. What is our value of b? So here we can start simplifying. We already know that 3 times 2, those are our coefficients, equals 6. So that's a good start. 6, and then we have x to the third, x to the fifth, equals 6x to the b. Since we have our x's here combined, we know we have to use our product rule. So 3 plus 5 is going to end up equaling b, so b equals 8. Try student example number 2 on your own. Now for our last student example, we're going to show that the quantity of 9x to the fourth, all taken to the negative 1/2 power, equals 1 over 3x squared. So here we have a negative fractional exponent. Since we have a negative exponent and our coefficient is a part of what's being taken to the exponent or to that power, we're going to take all of it and write it as 9x to the fourth power to the positive 1/2. Okay, and now since I have that 1/2 exponent, I'm going to apply it to my coefficient and to my variable term. So I have 9 to the 1/2 power and x to the fourth to the 1/2 power. Now I know that the 1/2 power is the same as taking the square root. So I can do the square root of 9 here because that's a useful form, right? I know the square root of 9. That's something I'm going to be able to calculate. However, here if I have x to the fourth power to the 1/2 power, I can use the power rule and I get x, and then 4 times 1/2 is 2. So if I continue to simplify this one more time, the square root of 9 is equal to 3. So 1 over 3x squared. And now we can show this equals our starting point right here. Go ahead and try student example number 3 on your own.